This is the Discovery Learning Center, and this is the home of human-centered computing research here at CU. And we focus on technologies to support people in a variety of tasks at work, at home, at school, and in other areas. The work that we do here is around thinking about how to build technology to support people and their diverse needs. So combining technical innovation in building systems, but also in understanding how people work and what they might need. There are a few different labs here in this space. So one is the Project EPIC lab, which focuses on using information technology to support crises and to help support people such as emergency workers and others in natural disasters and other kinds of crises. The Sekuli lab focuses on educational technology and finding ways to support diverse learners in learning. And the Superhuman lab, which is our lab, focuses on building technologies to support people with a wide range of abilities in performing everyday tasks. So from different types of disabilities, but also for the general population, how do we make work and learning and creativity easier for everybody?
The project that I'm working on is called An Eye for Art. And this project aims to make digital images more accessible for people who are blind or visually impaired. So what our project aims to do is to use natural human behavior while people look at images to collect eye gaze data and audio recordings and use computer algorithms to create more accessible images. So each of the objects can be activated by touch, and then there will be a description of that object that's played by the system.
A bear sits on one side of the stream, next to some mushrooms.
And then these regions are Voronoi regions, and they're dynamically generated based on the closest object to where you can touch. So if I touch here, it'll give me directions to this object. This is intended for people that can't actually see the image.
Move 0 inches below your finger and 5 inches to the right. Move 1 inch below your finger and 3 inches to the left.
The moon hangs in the sky behind the animals.
The project I'm working on right now is creating accessible programming languages for people with visual impairments. In schools, middle school and high school kids learn how to code, but they use a lot of visual coding environments to learn programming, but someone with a visual impairment can't access that. So we came up with a tangible programming language that uses physical blocks that can create audio stories, and you can also learn programming concepts through that. When somebody uses this language, which we call it story blocks, they are going to assemble physical blocks together. These blocks are shaped differently so that they can be identified by touch. They're going to assemble these blocks together to make a story, but that story will also reflect on some programming concepts. And once they've created that story, they can hear back the story that they've created with different voices and sound effects.
So I'm working on the haptic video player, which is about conveying spatial properties in videos to people with vision impairments. And basically, there's a lot of implicit spatial references and things that are not captured through any other modality other than vision. So if a user was blind, they would basically place the robots on the sides of the displays. The robots wait for an annotation, and once the annotation begins, they will actually move out and kind of speak what's going on in the video, allowing you to feel different motion and different translations. So the general concept is that the robots directly convey in kind of a one-to-one manner what's going on so that you can feel what's going on in the video rather than actually look at it.